and naming ionic compounds. Specifically, a little bit of a review section for some of you that need it, where we're going to look at identifying ionic compounds and ionic bonds. So looking for those metals and nonmetals, and most specifically drawing ions and looking at the number of valence electrons. So the learning intention for everyone today is to identify, name, and write ionic compounds. I need you to write this on your next notes page in your in your notebooks. This can be either in Cornell note format, or it can be in an alternative note format. However, you will have to show your notes to your teacher at the end of this lesson. Feel free as well to pause the video as you go so that you can write things down. So our starter today is looking at ions. What do atoms lose or gain, or why do atoms lose or gain electrons rather, and what happens when they do? Take a minute to answer this question and discuss with your neighbor if they are also doing this same lesson. So if you answered that atoms gain or lose electrons to try to become more stable, then you are correct. So to form a chemical bond, to become more stable, that is what happens. Okay. In this particular type, when they're gaining or losing, it's going to form an ionic compound. Okay, so an ionic bond will happen by that transfer of electrons. And what happens when they do is that they form ions. Okay, so that's what we're going to be reviewing in this lesson. Our success criteria for part 1, identifying ionic compounds and describing ionic bonds, is that you should be able to, by the end of this video, explain what types of elements form an ionic bond and describe how electrons are transferred to form an ionic bond. So a quick review. You will need to write this down because if you're watching this video, it means you didn't have a high enough score on your quiz. Ions review. An ion is an atom that is no longer neutrally charged. Okay, remember, neutrally charged means it has the same number of protons, the same number of positives, and the same number of electrons, the same number of negatives. Okay, and this usually happens so that an atom can achieve a full valence shell, a full outer shell, which is what they want to be happy. They want to have that stable energy, and that happens when the valence shell is completely full. Even if it means they have to go down one level, like the metals will, it means that the level below is completely full, and then that makes them happy or stable. Okay, so remember that a neutral atom can either lose electrons to form a cation, or it can gain electrons to form an anion. So pause the video, copy that down, and then continue. Okay, just another picture here to show you. So a neutral atom, there's the same number of positive protons and negative electrons. Okay, if it loses electrons, so one of those electrons goes away, it now has more positive charges, so more protons, it becomes a cation. Okay, if it gains an electron, then you can see we now have 4 electrons here and only 3 protons. It's gained a negative charge, it becomes negatively charged, and it becomes an anion. So a quick comparison of cations and anions. Again, you'll have to pause the video and record this in your notes. Cations are positively charged, so they've lost an electron. Okay, this is what happens to metals. So all of the metals will always lose electrons and they will always become cations. Remember, in your periodic table, the metals are to the left-hand side of the staircase. Okay, there are way more metals in the periodic table than there are non-metals. Basically what this means is it has a low number of valence electrons to start with, and it's easier to lose that electron than it is to try and gain more electrons. So for example, sodium initially has 11 protons and 11 electrons, and then this one lovely red electron here, it only has 1 electron in its valence shell. So for those of you that struggled with valence electrons, remember you have to look at how many electrons are in the last shell only. Okay, so here there is 1 electron in the valence shell, and it's going to lose that electron to become positively charged. On the other side of the periodic table, so in that right upper hand corner of the periodic table, you have the anions. The anions will become negatively charged. This only happens to the non-metals. Okay, so non-metals will always become negative, and that's because they already have an almost full valence shell. They just need a couple more electrons to get stability. And so they gain a few electrons because it's easier to gain the electrons to fill their shell than it is to lose all the electrons that they have in their outer shell. So if we ignore this red dot here, fluorine has 1, 2, 3, 4, 5, 6, 7 electrons in its valence shell. It only needs one more electron to become stable. And so what will happen is it will go and take that electron from a metal to fill its outer shell. Okay, once you've recorded those notes, please continue the video. So an example of positive ions or cations, once again, we have sodium here. You can see sodium initially has 3 energy levels, so 3 orbitals, 3 sets of rings or energy levels that the electrons can be in. And in its last shell, it only has 1 electron. Okay, so it's easier to lose that whole shell and lose that 1 electron to go down to only 2 energy levels where it has a full shell with 8 electrons. Okay. What would happen with fluorine? So we've done this already, we've shown it, we've explained it, but now I would like you to draw it in your notes. Okay, so fluorine here has 1, 2, 3, 4, 5, 6, 7 electrons in its second shell or its outer shell, its last shell. Okay, again, that's the valence shell, and it has 7 valence electrons. So what do you think fluorine is going to do? It's going to go and find another electron. Okay, so it's going to go find 1 more electron to now have 1, 2, 3, 4, 5, 6, 7, 8 electrons in its valence shell. It is now fluorine negative, so you'd actually need to add the negative symbol. Whoops. And I'll try to add that after the video. Okay, you need to add the negative symbol here to indicate that it now has 1 extra electron from its normal atom. So now it's your turn, and in the top half of your page, I need you to do the output. This is to draw the atoms changing into the ions, very similarly to what we've shown here in the practice. Okay, so you're going to try with beryllium, chlorine, magnesium, and sulfur. The first thing you need to do is decide, is it a metal or is it a non-metal? If it's a metal, what's going to happen? It's going to lose its electrons and become positively charged and become a cation. If it's a non-metal, it's going to gain an electron and become negatively charged. Once you've drawn those in your output, then what you need to do is you need to show it to your teacher to get it checked. Okay, summary, remember that ionic bonding is always between metals and non-metals. The metal will lose the electron and the non-metal will gain the electron. And this is done to have a full outer shell to follow the octet rule and to achieve stability. Metals losing electrons become positive ions, and non-metals gaining electrons become negative ions. Positive and negative ions have an attraction, and that's actually what forms the bond. So we didn't go over that a lot in this video. We had previously looked at it before, but because they become positively and negatively charged, they're attracted to each other. So make sure you finish those diagrams and the output before continuing.